Black holes are dark, matter-devouring balls of gravity. Most of them are so far away that we don't need to worry about them, but not this one. Meet Gaia BH1. This enormous black hole sits right outside our solar system. More specifically, 1,600 light years away from us. Now, that might sound like a huge distance, but it's way closer than any other black hole on record. What's worse, we didn't even know about it until now. Despite Gaia BH1 being 10 times more massive than our Sun, we couldn't see it. Scientists usually discover these monstrosities by spotting the gas that a black hole feeds on. These hungry giants are called feeding black holes. Only Gaia BH1 isn't anything like that. This black hole is dormant. It hides in the darkness, patiently waiting for the galaxy to throw it some cosmic matter to feast on. But there's one thing that gave away Gaia's presence. You see, most star systems in the universe are binary. That means they have not one, but two stars orbiting each other. Our black hole neighbor is also part of a binary star system, except instead of two stars, this system has one star and one black hole. Yeah, Gaia BH1 was disguising itself as a star. But even though this monstrosity doesn't feed on any gas or matter yet, it still couldn't help but jiggle its star counterpart a little. Yeah, good try, Gaia, but we still caught you. Out there in space, there are black holes a lot scarier than Gaia BH1. And some are so bizarre that they shouldn't even exist. A team of scientists discovered an unbelievable black hole and gave it the melodic name LB1. The weird thing about this black hole is that it's just too massive to be true. Okay, let's get some facts straight. We know of two types of black holes. Stellar black holes are what massive stars become when they die. They're everywhere in the universe. Even in our Milky Way galaxy, there could be as many as 1 billion of them lurking around. These beasts can be between 10 and 24 times as massive as our Sun. The other type of black holes are supermassive ones. These enormities sit at the center of almost every galaxy, including our own. We don't really know how they form, but we do know that they're unimaginably gigantic, billions of times more massive than our Sun. But LB1 doesn't fit either of these types. At 70 solar masses, it's too enormous to be a stellar black hole, yet it's too tiny to be a supermassive one. Scientists were scratching their heads trying to explain this phenomenon. Some theorized that it might not be a single black hole, but two black holes orbiting each other. Others guessed that LB1 was born of a gigantic star that was still in the middle of becoming a black hole. Well, the answer was simpler than we thought. LB1 isn't a black hole at all. It's an optical illusion caused by two rare stars orbiting each other. It's a unique star system to stargaze. But when scientists said they found an improbable black hole, well, they were wrong. But please, how could you blame them? It's pretty hard to study an object 15,000 light years away. Mistakes happen. The good news is that LB1 didn't upend our understanding of black holes after all. Now, that doesn't mean that black holes can't blow your mind. Remember the one at the center of the Milky Way? Yeah, it's called Sagittarius A star, and it's as massive as 4.5 million suns. But there's always a bigger fish in the universe. Sagittarius A star might be the most massive monster lurking in our galaxy, but it's not even close to some of the really big players out there, like Ton 618. This black hole is devouring matter 10 billion light years away from us. It's as bright as 140 trillion suns. So bright that it outshines its own galaxy. And its mass? Yeah, 66 billion times that of our sun. Yeah, that's right, 66 billion. Ton 618 is horrifyingly big. When scientists discovered it, they began to wonder if even more massive black holes were possible. Of course, the name supermassive wouldn't do bigger black holes any justice, so astronomers came up with a cool name for them too. Stupendously large black holes, or slabs. Yeah, and then they found one. Move over, Ton 618, there's a new gargantuan black hole in town. This stupendously large monstrosity sits at the center of Phoenix A galaxy, around 8.5 billion light years away from us. It's almost impossible to imagine how enormous this thing is. Scientists think it has a mass of 100 billion suns. That's more massive than some galaxies out there. And it won't stop growing. The event horizon of this black hole at the center of Phoenix A is unimaginably huge too. It has a diameter of about 100 times the distance between the Sun and Pluto. If you jumped on a SpaceX Starship and tried to fly across this black hole, it would take you 2,500 years to complete that journey. Yeah, we're lucky that this monstrous slab is so far away from us that we don't have to worry about it swallowing our solar system whole. But there are two more supermassive black holes very close to Earth. And they're on a collision course with each other. Okay, when I say very close to Earth, I mean 500 million light years away from us, but still closer than a lot of the other scary things out there. Seriously though, we don't know what exactly happens when two supermassive black holes collide. We've never observed a full merger of supermassive giants. Scientists think that they'll dance around each other for about 200 million years before finally becoming one. But this would be a violent marriage. As the black holes spiral together, they'll send enormous gravitational waves through space. Waves so big that we'll be able to detect them from our planetary neighborhood. But that's not the scary part. Mergers like that happen all the time, and right now, the Milky Way is on a collision course with the Andromeda Galaxy. When our two galaxies become one, what will happen to the supermassive black holes at their centers? Will they merge too? Would an event like this tear everything in its vicinity to shreds? Yeah, I bet that's what keeps astronomers up at night. In the center of our galaxy, the Milky Way, there's a supermassive black hole feeding on nearby stars. It's called Sagittarius A star. And if a giant gravitational monster slowly eating the galaxy isn't terrifying enough, there's another cosmic monstrosity lurking around it. Is it possible that one day they would get a little too close and collapse on each other? What would be left of the Milky Way if they did? Would there be even a slight chance that the Earth could get out of that safely? This is What If, and here's what would happen if a Magnetar collided with a black hole. This monstrosity creeping through the Milky Way is a remnant of a giant exploded star. But it's not just any remnant. It's an extremely dense and very magnetic collapsed stellar core, a magnetar. Let me refresh your knowledge of magnetars. They're born when a star, at least 8 times more massive than our Sun, reaches its expiration date and explodes in a beautiful supernova. Much of that star is gone, but the dense core of it remains. Most of these remnants become neutron stars. They spin very fast, usually a few times per second, and they're composed of neutrons. Some neutron stars have such strong magnetic fields that they emit electromagnetic radiation from their poles. That makes them pulsars, and you can observe them with a telescope when their poles face the Earth. Only a few pulsars develop such an extremely powerful magnetic field. They become the strongest magnets in the universe, the magnetars. They spin once every 10 seconds, but their magnetic field is 100 times stronger than that of a neutron star. If one of those magnets came halfway between the Moon and the Earth, well, it wouldn't be pretty. But would it be as bad from a distance of 26 light years? Once the black hole consumed the magnetar, its mass would increase and expand its event horizon. And thanks to this expansion, more and more stars would be flung into its dark density. The black hole would be slowly eating our galaxy, star by star. Eventually, after quadrillions of years of star consumption, the black hole could gobble up the Milky Way, all of it. By that time, humanity would most likely be long gone anyway. Something is very wrong with our sun. It's turned into a spinning lighthouse of death. What would make the sun so much more deadly than usual? Is there any way life on Earth could survive this? And why would it feel like you're stuck at the bottom of the ocean? This is What If, and here's what would happen if Earth was a pulsar planet. Many stars go out with a bang, exploding in brilliant supernovas. But our sun has gone straight to becoming a pulsar, sometimes called a neutron star. You could take this as some good news. The sun exploding would obliterate Earth and take nearly the rest of the solar system along with it. But now that it's a neutron star, the sun would be among the densest objects in the universe, and one of about 200,000 pulsars in the Milky Way, shrinking itself about 70,000 times the size it used to be. Our sun wouldn't be much bigger than a small city at 10 kilometers across, and it would be spinning very fast. If it's anything like the pulsar located in the Virgo constellation, it could make about 161 rotations every second. Oh, and it would also shoot beams of deadly radiation directly toward the Earth every few seconds, or even milliseconds. Okay, the first thing you'd notice would be that things suddenly got a lot darker. Our sun would emit almost no visible light, but you'd still be able to catch quick glimpses of it. though only for the extremely brief moment that its pulse of energy is directly pointing at us. The sun would now be like a pulsing lighthouse at the center of our solar system. This eternal darkness would cause a lot of problems back here on Earth. There would be no more photosynthesis. Trees would no longer be able to produce oxygen and crops wouldn't grow, so animals and humans would be on the brink of mass starvation. But there would be good news. Astronomers have found exoplanets existing in a pulsar's habitable zone, so maybe, just maybe, you'd have a chance to survive this.
Run, OJ! Run!
Especially because the habitable zone of a pulsar could be nearly as large as a normal star. That would mean it could still be possible for liquid water to exist on Earth's surface. But this liquid water would only be able to exist thanks to our warm atmosphere, trapping energy from the sun. And while there wouldn't be much visible light, there would be a lot of radiation. That's because neutron stars have incredibly strong magnetic fields. This would cause beams of X-rays and gamma rays to shoot out from the sun's poles. Yeah, and this would be very bad news. All this radiation would be highly lethal. In order to prevent it from reaching the Earth's surface, our atmosphere would need to be thicker, maybe as thick as 1 million times what it is today. If you managed to pump enough air into the atmosphere to reach this desired thickness, you'd have to get used to living with an atmospheric pressure as intense as the deepest parts of the ocean. It would be like going down 10 kilometers to the bottom of the Mariana Trench. But you wouldn't be able to get close to that depth before you'd be completely crushed. Before you even hit the halfway point, your eardrums would rupture and your lungs would fill with blood and collapse. But you might not need to worry about this because Earth wouldn't be able to hold such a dense atmosphere in place. The relentless radiation would just blast it away. And if enough of the atmosphere disappeared, the liquid water on Earth's surface would eventually boil away. And that would be the guaranteed demise of human life on this once habitable space rock. "120 light years away from us, there's an exoplanet that can potentially host life. It's called K2-18b, and it's a world you'd want to visit. K2-18b isn't exactly like Earth, it's more like a super Earth. Yeah, it's 2.6 times larger and almost 9 times more massive than our planet. Scientists think it could be a Haitian exoplanet, which is just a fancy way of saying that it likely has a hydrogen-rich atmosphere and is covered in liquid ocean. That means that K2-18b could be home to alien life. Only it would take a really long time to get there. If you were hurtling toward this space rock from Earth, you'd reach your destination in about 1.3 million years. Yeah, you heard right. Million. K2-18b has a lot of methane and carbon dioxide in its atmosphere. That's not exactly breathable air, so you'd still need a spacesuit to walk on this world. And I wouldn't be too hyped up about its ocean either. If an exoplanet has liquid on it, it doesn't mean that the liquid is water. It could be methane or ammonia, even acid. Like, even in our own solar system, there's a moon covered in liquid lakes, but these are methane and ethane lakes, and I wouldn't recommend swimming there. K2-18b could have a pretty mild temperature. For an exoplanet, that is. At minus 100 degrees Celsius, you'd find this world incredibly cold. Now, the most exciting thing we've found out about this world is that it could have traces of dimethyl sulfide. Woot woot! Well, on Earth, this molecule can only be produced by living things, and that means K2-18b could be home to alien life. Now, it doesn't mean that this life would be intelligent. It could be aquatic or microbial. Maybe even complex life if the conditions for it are just right. We won't know for sure unless we travel to explore this interstellar world. Now, how do we know all this? Well, we had the James Webb Space Telescope look at this distant world and take detailed measurements of its atmosphere. Most of the exoplanets have been discovered using what's called the transit method. It's when a planet passes in front of its star and blocks its starlight. That's when scientists study the wavelengths around the planets, and some of those wavelengths can tell us what kind of atmosphere those distant planets have. The problem is, exoplanets are really far away. Trying to figure out what their surfaces are like just by peering through even our most powerful telescopes is not easy. Some scientists will argue that K2-18b isn't a super Earth at all, but a mini Neptune. And that's a bummer because, as you know, Neptune is an ice giant. And if K2-18b is also an ice giant, then the chances for alien life on this planet don't look so good. Now, you don't have a million years to travel to this world to discover it for yourself, so maybe we should look at a world that's a lot closer to Earth. Like Proxima Centauri b. Proxima Centauri is the closest star we've discovered, only 4.2 light-years away from Earth. It's part of the Alpha Centauri star system, with not 2 but 3 stars orbiting each other. The exoplanet Proxima Centauri b orbits only one of these stars, but you'll still see the other 2 stars as bright dots in the sky. This exoplanet is slightly larger than Earth and revolves uncomfortably close to its host star. Luckily, that star is a red dwarf, and that's much cooler and smaller than our sun. Which is good news because that means this planet isn't getting toasted like Mercury. Scientists estimate Proxima Centauri b has an average temperature of about -39 degrees Celsius. That's pretty comfortable as far as alien worlds go. The bad news is that we still don't know much about the exoplanet's gravity or atmosphere. It might be our best candidate to set up an interstellar base, but it also could have a harsh environment, unsuitable for humanity's future home. It might even have an ocean of acid, or something deadly like that. The only way to find out is to travel there. And if Proxima Centauri b doesn't work out, well, don't worry, there are plenty of potentially habitable worlds out there. Like this one. Ross 128b is 11 light-years from Earth. It's the second closest potentially habitable world scientists have discovered. And it's more promising than Proxima Centauri b. The thing is, they both orbit red dwarf stars, only Proxima b's host star is a lot more active and violent. It occasionally erupts and bathes Proxima b in radiation. Ross 128b's star is nice and quiet. And even though this world orbits 20 times closer to its star than Earth is to the Sun, it still lies in the habitable zone. Because like I said, red dwarfs are way cooler than the Sun. And by cooler, I just mean temperature. This world could have a balmy average temperature of 23 degrees Celsius. That's only slightly hotter than the average temperature here on Earth. I don't know about you, but I could settle there. Now, we don't know enough about this world to call it our new home. It likely has lots of harmful radiation reaching its surface, and its atmosphere might not be breathable. But hey, that's not much worse than Mars. With efficient life support systems in place, we could make it work. Besides, this super Earth might have its own life on it. If Ross 128b did have alien life, it could be extremely different from what you might imagine. Just think about making the first contact with an alien species. What would that be like? I mean, it could go very wrong, too. For one, we might not survive the trip to any exoplanets, even the nearest ones. So far, we've discovered and confirmed over 5,000 alien worlds. 63 of them are potentially habitable, but we just can't know for sure. A rogue star is headed straight for our sun. If these two stars slam into each other, it could spell the end of all life on our planet. How could a rogue star end up in our solar system? What would this epic collision look like? And how much time do you have to live? This is What If, and here's what would happen if a rogue star collided with the sun. As the name would suggest, rogue stars drift through space. They don't belong to any particular galaxy, or if they once did, they've been ejected from their homes at some point by supernovas or two galaxies ramming into each other. Whatever it is that sends these stars hurtling away from the gravitational pull of their original galaxies, it fires them off at very high speeds. In order to break free of our own Milky Way galaxy, a star would need to move as fast as 550 kilometers per second. Luckily, our sun is only moving at a mere 200 kilometers per second, not nearly fast enough to become rogue. But these wandering stars aren't all that uncommon. They may even account for as many as half of the 200 billion trillion stars in the universe. And one of them could be headed toward our sun right now. Meet Gliese 710. This rogue dwarf star is on a trajectory that would bring it close to our solar system in around 1.3 million years. When Gliese 710 eventually reaches us, it would enter the outermost section of our solar system, the Oort cloud, at a speed of about 51,500 kilometers per hour. It could send the icy bodies out there flying in different directions, maybe even right toward Earth. Once it has reached Neptune, the countdown to the epic collision would begin. T-minus 10 years till the impact with the sun. At this point, you'd better just plan to live your best life while preparing for the upcoming apocalypse. The gravitational pull of Gliese 710 would destabilize the orbits of our planetary neighbors, nudging them left and right. This could go as far as pushing Earth out of the habitable zone. Or it could turn us into a rogue planet after unceremoniously being catapulted out of the solar system. After 10 years, it would finally be getting close to collision time. As each day passes, things are only going to get worse. One possibility is that the Sun and Gliese 710 would merge into a red nova. This would result in a violent explosion that would unleash nearly 500,000 times more light than what the Sun does right now. Given the amount of time light takes to travel from the Sun to the Earth, you would be blissfully unaware of this destructive explosion for 8 minutes. But the moment you do find out, all that light would likely blind you in a millisecond and then immediately fry you on the spot. That's because directly behind this blinding light would be super hot gas. This wave of heat could be powerful enough to wipe out nearly everything in its path. Bye-bye Mercury, Venus, and yeah, Earth too. Our atmosphere and oceans would be completely blasted away. This would leave our planet as nothing more than a barren rock. The explosion would also have created massive amounts of high-energetic neutrinos. These would be able to boil you from the inside out. Earth would also be shrouded in lethal levels of UV and gamma radiation. Even if you somehow managed to survive the explosion, you wouldn't last long from the harmful effects of all this radiation. You'd have damage to your eyes, skin, and even DNA. Now, if an alien species was watching this all unfold from a distant galaxy with an incredibly powerful telescope, they'd see a single bright star surrounded by an excess of reddish-colored gas. And the infrared light left behind from the explosion would be visible for a long time after. But that wouldn't be the only way all this could possibly go down. There is a possibility there could be a more peaceful alternative. Yeah, if the two stars are moving a bit slower relative to each other, they could end up merging into one massive new star as they orbit each other. Our Sun would strip mass from its smaller companion, Gliese 710, and swallow it in a process known as stellar cannibalism. Then, this extremely hot and bright star would be called a blue straggler. Though it may sound many times more peaceful, this option would still likely spell out the end of life on Earth. With our Sun now a massive blue star, the habitable zone of our solar system would be pushed further away. Black holes are one of the most devastating objects in space, sucking up everything around them. But there's another space phenomenon that's just as destructive. And it's known as a white hole. Now, what would happen if these two objects met in space and fought each other? Could something like this even happen? Who would win? And what is a white hole anyway? This is What If, and here's what would happen if a white hole fought a black hole. Before we get to our fight, let's see what these two opponents are all about. In one corner of space, we have the black hole. This legendary space occurrence is probably pretty familiar to you. Its signature move is to consume every piece of matter it comes in contact with. The white hole, you're probably less familiar with. And its signature move is to expel energy rather than sucking it in. So, with our two fighters having completely opposite attack strategies, who would win? Despite us not knowing much about our white hole mystery opponent, it's much more experienced at conquering space than the black hole is. That's right, the white hole is a proper journeyman and has been roaming space for millions of years, kicking butt and taking names. That's because scientists theorize that this white hole used to be a black hole. Scientists suspect that after millions of years, black holes will become white holes. And all the energy and matter they consumed over the years will be expelled back into space. That being said, when a black hole becomes a white hole, it might not last very long, so it will need to act quickly if it wants to pick a fight with a black hole. And despite it being different, the white hole is just as destructive as a black hole, if not more so. The matter the white hole is ejecting moves at the speed of light. So it's safe to say that the white hole is the veteran fighter in this situation as opposed to this up-and-coming black hole, but how much will its experience help it? After millions of years of causing destruction throughout the universe, our two opponents finally meet. They've battled asteroids, planets, and even stars, but they always managed to survive. Now, they both face their greatest opponent yet. As these two massive forces approach each other, the black hole will instantly gain the advantage. The white hole will do its best to prevent the black hole from overtaking it, but unfortunately, it really doesn't stand a chance. That's because the white hole has no choice but to spit energy at its opponent. Although it was able to defend itself against everything else in the universe, unfortunately, the black hole is its one true match. The mass the white hole is expelling is also being turned into energy for the black hole. This won't be a quick battle either, as the black hole can feed on the white hole for thousands of years. And as it keeps feeding, the black hole is getting larger and larger. And now the black hole is ready for the finishing blow. It completely swallows the white hole. Now that it's consumed so much energy, our black hole is more massive than ever. It might be as big as the Messier 87, which is 38 billion kilometers across. For reference, that's 3 million times larger than Earth. So, if a white hole and a black hole collided, we'd have a massive black hole roaming around the universe, destroying everything in its path. And if it were anywhere near us, well, that would mean humanity would be in some pretty big trouble. Imagine you're out for a walk on a lovely day with not a care in the world. The birds are singing and the sun is shining. Actually, the sun seems brighter than usual. And come to think of it, your skin feels kind of funny. It turns out that's not the sun at all, but the radiation and gamma ray filled light coming from a quasar. So, in short, you're in serious trouble. How did a quasar even get here? And what would happen to Earth if a quasar moved into our neighborhood? This is What If, and here's what would happen if a quasar entered our solar system. I hope you didn't have any plans today, because the brightest object in the sky has set up shop in our solar system. So what exactly is going on anyway? A quasar is the result of two black holes colliding to form a supermassive black hole, with a central mass that outweighs our sun by 1 billion times. When black holes merge, everything goes out of whack. The two black holes begin to consume all the gas and dust from each other, along with anything else in the area. Okay, so if they're eating each other, why are we seeing that bright light? Well, the material that's thrown off begins to glow from pressure and friction, resulting in the blinding light you're seeing. If this were to happen in Earth's vicinity, it would be a result of the black hole in the middle of the Milky Way galaxy smashing into the black hole at the middle of the Andromeda galaxy, which is 2.5 million light years away. If these two met, we'd be looking at a massive amount of infrared light being expelled into the universe. Oh, and it's also a harbinger of death and destruction too. What would happen to our planet? Well, brace yourself, because this is going to be a doozy. Quasars throw off jets of particles that are so bright they outshine all the stars in their galaxies. So our sun would essentially turn into a candle in the middle of a very bright spotlight. The illumination from a quasar, along with all the radiation it throws off, would mess with Earth's atmosphere. The light is enough to energize particles that make up the atmosphere and free them from Earth's gravity. Our atmosphere would be destroyed, and we really need our atmosphere. It's our protective layer that keeps things in order and regulates the temperature. Without it, the oceans would dry up, Arctic ice would turn into water vapor, and everything would get much, much hotter. In addition to it being blindingly bright, we would have no safe air to breathe, no plants to eat or feed animals. and there would be no water to drink. Life on Earth would be a write-off. This would all happen very quickly, so you wouldn't have to live through a long, drawn-out apocalypse. At least you can look forward to that. But could this sort of doomsday scenario actually occur? Well, yes, but not for another 3 or 4 billion years. At that point, the sun will be flickering out. And by that time, we're pretty sure something else we've covered on What If would have taken us out first, so we won't even be around to see it. If you could teleport the Earth to any place in the universe, what would you want to look at in the night sky? The bright explosion of a supernova? A black hole passing over your house? How about a nebula? What would this gorgeous gas cloud look like up close? And how would the Earth change if it were inside it? This is What If, and here's what would happen if we lived inside of a nebula. What is a nebula anyway? A nebula is a giant cloud of dust and gas in interstellar space. They are vast, sometimes taking up hundreds of light years of space. But with all that size, they aren't massive. A nebula the diameter of the Earth would only have a mass of a few kilograms. That's because nebulae aren't very dense. And that's why, if we lived inside one, it wouldn't look anything like what you might expect. Some 1,344 light years away from Earth is the Orion Nebula, the brightest nebula in our sky. It's 24 light years across and has a mass equivalent to 2,000 suns. If the Earth was formed inside it, all you'd see in the night sky would be this. Not impressed? I know, I wasn't either. It turns out it's not that easy to see a nebula when you look at the night sky. To your eye, most galaxies in the universe don't look anything like this. More like this. And most nebulae are invisible altogether. Your eyes aren't sensitive to the kind of light a nebula produces. But look at the image taken by the Hubble Space Telescope and you'll see a beautiful gas cloud. That doesn't mean these beautiful images of space are fake. Their colors just represent the light waves that your eyes aren't able to detect. So, if you had the Hubble telescope, would you be able to see a nebula if you lived in one? Sorry to disappoint you again, but no. Nebulae are pretty only when they're hundreds of light years away. They look thick and cloudy only because you see the structures of light years in thickness. Once you're close to them, their light spreads out so much that you can't see them. You could fly your spaceship right into the nebula and never even know it. If the Earth were inside a nebula, the only effect you'd see would be brighter auroras, unless the solar wind blew all the nebular particles far away from the planet. How do we know we're not living inside a nebula right now? Well, simple. After gathering the data on our own sun, we can calculate the expected brightness of the neighboring stars. If we did live inside a nebula, we'd notice that our star was much brighter compared to others. The nebula would be dimming the light coming in from outside of it.
This is the most powerful object in the universe. The biggest spinning magnet to ever exist. It's the cosmic equivalent of a great white shark. But it wouldn't eat you. It would just turn all your atoms to dust. This is What If, and here's what would happen
If a Magnetar entered our solar system. If you thought neutron stars were big and scary, well, you haven't heard of their more powerful stellar cousins yet. Like neutron stars, magnetars are leftovers from supernova explosions. They're just packed with a lot more matter. Their density is so high that a single teaspoon of a magnetar could weigh in at 1 billion tons. They're also the most magnetic stars we know about. We use a unit called a Gauss to measure the strength of a magnetic field. Earth's magnetic field is only about 0.6 Gauss. The magnetic field of a magnetar can be as strong as 1 quadrillion Gauss. How long would it take a stellar monster like that to rip our planet apart? It wouldn't be the worst thing in the world if a magnetar was sitting quietly in our galactic neighborhood, But if it decided to stop minding its own business, there are two ways a magnetar could end all life on Earth, together with the planet itself. It could get too close to the planet. You'd start to feel its presence when it was about halfway between the Moon and the Earth. At that distance, a magnetar would erase the information off all your credit card's magnetic strips. Whatever you do, try not to get closer than 1,000 kilometers from a cosmic invader. Because if you did, your atoms would get stretched out of shape. Your bioelectric field would get scrambled, disintegrating your molecular structure. And your body would just disappear. Alternatively, a magnetar could destroy us from much, much further away. As if being the biggest spinning magnets in the universe isn't enough, magnetars can also be affected by something called starquakes. Starquakes happen when a star's crust cracks, letting massive amounts of radiation out into space. This blast of radiation could compress the Earth's magnetic field and partially ionize the Earth's atmosphere, even from 50,000 light years away. We know this because we've already come a little too close on at least one occasion. In 2004, gamma radiation from a magnetar reached our planet from outside our Milky Way galaxy. In just 1/5 of a second, it released more energy than our Sun has released over the last 250,000 years. Move that magnetar and its starquake up to 10,000 light years away, and things would get much worse. First, it would destroy our ozone layer. Then, it would wipe clean most of the planet's surface, along with all life as we know it. The truly scary part of this is that we wouldn't even know the magnetar was heading towards us. It would be a blink and you're gone scenario. I won't lie to you, there are magnetars close enough that if one had a violent starquake right now, we'd all get wiped out very fast. When scientists began their search for these interstellar monsters 40 years ago, they didn't realize how many of them exist out there. You might find some comfort in the fact that most magnetars don't make it much past their 10,000th birthday. Their short lifespan ends with them becoming neutron stars. Still dense and still magnetic, but not nearly as dangerous as a magnetar. But if one of them came near our solar system, well, that would be a story for another What If. Black holes are dark, matter-devouring balls of gravity. Most of them are so far away that we don't need to worry about them, but not this one. Meet Gaia BH1. This enormous black hole sits right out